Hello guys, this is Nehal. So today we are going to do the hard question compilation for computer science paper 1 of Cambridge AS level. So if you have already done with the question papers, you should have been done with the question papers by now for the 5 years that we have of 9618. So if you're done with the question paper and there is not enough question paper available in the internet, so that is why I made these hard question compilations. So these are questions which might be a bit unique, the pattern of the questions might be different, or these are questions which the students faced problems in. All right, so I made this document using the examiner's report where they have reported that most mistakes were done in this question, or the reasons why students face issues while answering the questions. All right, so if you do this paper, you should be getting a good preparation for your board exam. And we are going to do a lot of questions in this video, so if you find any questions which seem too easy, you can just skip it and continue with the next question. All right, so let's start. This paper consists of questions from May June 2021 to May June 2025. All right. Coming to the first paper, May June 2025, variant 11. So this question: the Unicode character has the hexadecimal value of 2140. Convert the hexadecimal code for the character into denary. All right. This question is actually not hard. It's just a bit lengthy, and they only gave 1 mark for this, which is a bit odd. All right. So here we have 2, right? So we have 2 into 16 to the power of 2. Then we have 1 into 16 to the power of, sorry, this is the power 3, right? So we have 16 to the power of 3. Now we have 1 into 16 to the power of 2, then 4 into 16 to the power of 1, and 0. So it's 0. So if we evaluate this, 2 into 16 to the power of 3, you should do the calculation. You should just do the rough work for the calculation. All right, so since that we don't have much time, I will just write the answer here. Right, next question. A company builds and sells furniture to customers. The company stores data about customers, their payment card, and their furniture orders in a database. The database furniture has the following table. So we have 4 tables here: customer card data, order. So you will notice something. Customer card data has this field, which is the foreign field, right? So this comes from here. All right. Then I have order. Here I also have customer. This comes from here, right? Then order item has the order item ID. All right. Order ID. So order ID comes from here. And these are the fields. The primary key are underlined in each table. The attribute complete in the table order stores the boolean value true if the order has been built and false if the order has not been built. Explain the reasons why the data in the table order item cannot be stored in a table order. So the question is asking why we cannot store this data inside this data. Alright. So you need to write the reason. So whenever you are shopping online, let's say this is a furniture shop, right? So you will want to buy multiple furniture at once. There might be a scenario like this. So if we store the order item inside the order, that means each customer will need to make multiple order to buy multiple furniture, right? So we want to have a way so that we can order multiple items without making a duplicate of the order table, right? So let's just write the answer here. Alright, basically each order would only be able to have one item, or the database would not be normalized. It would not be in first normal form due to repeated groups of attributes in the order table. Alright, coming to the next question. A banker stores personal data on their work computer. The banker receives confidential data across the internet. The data includes a digital signature. Explain how a digital signature can make sure the data has not been changed during the transmission. The main problem with this is whenever a student answers these questions, like this 5 mark question, they answer it too vaguely. All right, so you need to explain this a bit. So let's explain. So let's just draw a diagram at first to explain this. So I have two parts here, right? I have the sender and I have the receiver. All right, so the sender has a document and the sender will hash this document, hash with an algorithm, right? So we will run a hashing algorithm to produce something called a digest. So this is a digest. All right. So the digest is now encrypted again. Encrypt, and this will produce the signature, digital signature. All right. So the message and signature are both sent to the sender, receiver. So this thing along with the signature are sent to the receiver. Now the receiver will decrypt the signature to reproduce the digest. So whenever I receive this signature, the receiver will decrypt this, right? So he basically reverses the process. He will decrypt this to get the digest, and using the message that the receiver got, he will run the same algorithm on this message, right? So he will run the same algorithm on this message to generate the second digest. And now he will check that the digest that we got from the sign and the digest that we got from the data, if they're equal or not. If they are equal, that means there was no problem with the data, right? Meaning the data has not been altered during transmission. But if they do not match, that means the data has been altered during the transmission. So we need to write this in words. So basically the sender hashes the document or the message to produce a digest. The sender encrypts the digest to create digital signature. The message and the signature are sent to the banker or the receiver. The receiver decrypts the signature to reproduce the digest. The receiver uses the same hashing algorithm on the document received to produce a second digest. The receiver compares these digests with the one from the digital signature. If both of the receiver's digests are the same, the document has not been changed. So every bullet point is equal to 1 mark. So you need to write max 5 marks from here. Next question. The data that is transferred can also be verified using a checksum. Explain how data can be verified with a checksum. Alright, so let's try this. So we have the data here, right? So using the data, I will calculate something with some algorithm to get a checksum, right? So now I will send the checksum and data to the receiver. All right. So the receiver will get both of it. Sender will check the checksum and the data. All right. So now the receiver will perform the same algorithm on the data. All right. So after that, he will get another checksum, right? So this checksum and the checksum that the receiver received will be compared. All right, these two will be compared, and it will be checked if they are equal or not. So again, in the same way, if they are equal, that means data has not been altered. If they are not equal, that means data has been altered. So let's write it down. So the data is put through an algorithm to create a checksum value. The data and checksum are sent to the receiver. The receiver performs the same algorithm on the data. If both checksums match, the data is verified. Alright, coming to the next paper, May-June 2025, variant 12. The table has 6 statements about the von Neumann model for a computer system. 3 of the statements are incorrect. Now we have to identify the incorrect statements and write the corrected statements. So let's read the statements one by one. The program counter stores the next instruction to be fetched from the memory. So first thing first, the program counter does not store the next instruction, right? So it stores what? Address of the next instruction, right? So this should be address of next instruction. All right, instead of next instruction, this should be address of the next instruction. Now the arithmetic and logic unit performs mathematical and logical operations, so this is correct. The control unit sends signal to other components on the data bus. So yeah, this is true that the control unit sends signals to the other component, but it doesn't use the data bus. What do we use? We use control bus. Control bus. All right, so this is wrong, this is wrong. The memory data register transfers data to the memory address stored in the memory address register. So the main thing here is the transfer, right? So memory data register does not transfer. All right, memory data register holds data to be stored in the memory address in the MR. So this line should be edited a lot. So let's mark it. All right. Now, the MR stores an address from the memory. This is true. The accumulator stores the result of the calculation. This is also true, right? So here, people sometimes assume that this is wrong, all right, but this is true. It does store an address from the memory, right? Even though the statement here is not that specific, but this is true, all right. So you should always understand registers, all right. Registers can never transfer data, they only store data, all right. So this is also for registers, and also in another chapter you will see something called buffer. These two does not store, does not transfer data, they only store the data, all right. So you need to be careful about this. This is a very common mistake that students do. Now let's write the answer. So these are the answer. Here the changes that I made was that here this part address, right? Address of the next instruction to be fetched from the memory, address of the next instruction. Then the controller sends signal to other component on the control bus. So the change I made was here, and in the last part the memory data register holds data to be stored in the memory address in the MR, right? So here the change I made was I changed this part, holds data to be stored in, right? The MDR holds data, the MDR holds data to be stored, all right, in the memory address in the MR. All right, coming to the next question. Write the smallest and largest 2's complement binary integers that can be represented in 8-bit. So students also do a very common mistake here. Basically, you guys should answer this in binary, right? Not in denary. This is a very common mistake students do. Also, they sometimes does not understand the value of 2's complement binary integer properly, right? So in 2's complement, what happens? The first digit is negative, right? So if you want to represent the smallest binary number, that means what? The smallest number is the one which has the highest negative value, right? So the first bit will be negative, and the remaining bits all will be 0, right? Because we are not going to add any value to this minus negative value, right? So this will be the smallest value, and the largest value is when the number is positive. So the first bit must be 0, and the magnitude should be the highest, so every single bit should be 1. This is the largest possible value. Coming to the next question. An online game has a database that stores data about users and the character each user creates in the game. Each user can create multiple characters and multiple items for each character. The normalized database has the following design. So this is the design. Explain the purpose of the table character item in the database. So we have 4 table here. User. So here this should be the primary key, right? Then password, date of birth, character name, character ID, username, level, and money. So this should be the primary key, and this field right here is going to be included here, right? All right. Then item name, minimum level, and cost. Item name should be the primary key, and character item. So here character ID and item name, both of them should be the foreign key. Also both of them should be included in the primary key, right? So here we know that we do something like this whenever we have a many to many relationship, right? So whenever we have a many to many relationship between two tables, so here character and item, so usually there would be a relationship like this: user and item, sorry, not user and item, character and item. So here item and character, they should have a many to many relationship, right? One item can be owned by many characters can own one item, and something like that. So we cannot represent this in a normalized database, right? So we use a normalized database here. So we have, let's say, ci in between both of them, so that we can create a many to many relationship, something like this. So I have item here, then I have ci, so I can do this and I can do this. Here comes the character, all right. So this is the relationship that I am imitating using the character item in the database. So let's write it down in words. So to remove the many to many relationship between character and item tables, to allow each character to have many items. So this is, you get 1 mark for each of the point. Next question. A company has multiple sites in different cities. The company has drivers who deliver products to customers. Each driver can connect to the company's WAN wide area network whilst out of office using a smartphone. The smartphone uses the cell phone network to connect to WAN. Explain how data is transmitted using this cell phone network. So the main problem is these questions like this come a bit less about cell phone networks. So students are were not usually well aware about cell phone networks. Alright. So let's explain the intuition a bit. So what happens in a cell phone network? I have many cells like this, right? This is a hexagon actually. So let's draw a circle instead of hexagon. So these are different zones. All right, these are different cells. So here, each cell, this will have a area that is enclosed by it, right? So this has a tower. There are many cell phone towers, right, throughout the country. Every country has cell phone towers, right? So these towers are spread throughout the area. So the land is split into cells, and each cell has an antenna, has a tower with an antenna which can receive and transmit data, right? So what happens is whenever you use a phone, you connect to your closest tower. Let's say you call someone else and he connects with the closest tower then to him. So you connect to the tower and the tower connects with each other, right? And after that it can connect to the cell phone of the other user. So we are using radio, low power radio signals here. And you can also have something like this: multiple phones can connect to the same cell, right? Multiple phones can connect to, so that is why whenever you call someone, another person from your area can call someone else, right? So this is how the cell phone network works. So let's write this in words. Basically, the land is split into cells designed for maximum line of sight. Each cell has a tower with an antenna which receives and transmits data. Data is transmitted between the tower and the phone. Data transmission is wireless using low power radio signals or frequencies. Multiple devices can communicate simultaneously with the same tower. Alright, next question. The main office for the company has four wired computers, one server, two printers, one central switch, and a device providing a single point of access to the internet. The network is set up as a star topology. Draw a topology for the main office network. Label all the devices. So basically this uses a star topology, right? So that means every device will be connected to a central device. So we have four wired computers. We have four PCs, right? So let's say PC1. We write computer actually. Computer 1. I can have this. I can have computer 2, computer 3, computer 4. Alright. So this is done. One server. Alright, just draw the server here. Two printers. So let's draw printer 1, printer 2. One central switch. So they already mentioned the central switch. The switch will be here between everything, right? Well, the spelling is not right, whatever. And the device providing a single point of access for the internet. So we have a router. Alright, router, we have a router here. Now every single device will be connected to the switch like this. And the switch will be connected to the server. So this is the answer. Now coming to the next question. So coming to the next paper. The computer connects to a monitor using high definition multimedia interface cable that connects into an HDMI port. Explain how HDMI provides connection to peripheral device. Again, this question, many students did mistakes in this question specifically because they did not, they studied about HDMI but they just forgot it during the exam, right? So let's just write the points. So the problem with question numbers is they have a lot of common questions and there are certain questions which doesn't appear that much. So students usually forget this during the exam. So that is why students struggle in this question. Alright, so the HDMI transfers both audio and video using a single cable. HDMI has a high bandwidth. Data is transmitted in a stream of uncompressed digital signature. So the data is uncompressed. Alright, and HDMI uses a technology called transmission minimized differential signaling. You do not need to know the last point. It's okay. You don't need to memorize this, but you just need to know the first 4 point to get an idea of how HDMI cables work. Alright. 5b. The table shows part of the instruction set for a processor. The processor has one register, which is the accumulator. Now you are giving some instruction. Write the bit manipulation instruction that can be used to set the most significant bit to 1 in an 8-bit register. Use can be used in the 8-bit register. Alright, so let's try this. So the students miss out something in this question. Basically, you need to read the question properly. All right, so the instructions need to work on a register that contains 8-bit binary number. So basically it doesn't matter. Let's say I have a binary number x y z a b c d e, whatever I have, it doesn't matter. I have to convert this into something, right? The bit manipulation instruction that can be used to set only the most significant bit to 1 in an 8-bit. I have to convert this number into this. All right, so a very common mistake that a student does is they use the operation or this operation. So the problem with this operation is, let's say I am considering the last bit, right? So if this was 1 and this is 0, I will get an output of 1, right? So that means I have set this bit to 1, the last bit to 1. So this is not all right. So at first I have to convert everything to 0. So to convert everything to 0, I use and I use 0, 0, 0, 0, 0, 0, 0. And since this is binary, I use a b here. Then I will do an or operation where I will set the most significant bit to 1. So this is the answer. Alright. A shop sells pen to customers. Customer place an order with the shop and collect the items the next day. The shop uses a database to store the information about the orders. The database contains the following tables. So I have customer, order, then order product, blah 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 blah. So let's see. So in order, I have customer ID. This comes from here, right? Alright, order product has order ID and product ID. These two comes from here. Then product has supplier ID. So supplier ID comes from here. And does supplier have an ID have any foreign key? No. So these are the foreign keys. Alright. So let's start with product. The supplier ID is being put inside the product, right? So that means one supplier can have many products. So we will have a branch like this for this part. Alright. Now let's focus on the order part. So one customer can make multiple order. This is the relationship here, right? So one customer and I have multiple order here. So this is done. Now let's account for product ID and order ID together. Alright. So here I am linking order and product using the table order product. So one order product might have multiple order ID or multiple product ID. That means this is a many to many relationship which is replaced by a linking table, right? So this will be like this. Product has a many to many, one to many relationship and order has a one to many relationship with this. Alright, next question. A new product needs to be entered into the database. The product has the ID 002323. The product name blue ball point 2 mm, and there are 50 in a box, and the product costs $5, and the supplier has an ID of SFX223. Write the SQL script to enter the new product into the table product. So we need to insert into product. All right, so we know that we can insert in two ways. Firstly, let's use this method. I have the serial given here, right? So I have product ID, product name, quantity, inbox, cost, and supplier ID. I need to enter this in order. All right, so let's type it down. So insert into product. and I have the values, right? So inside the values, I will use a bracket and give everything in a serial order. So I have the product ID. Product ID is 002323. Then I have the product name given here, right? So product name is blue, since this is a string, blue ball point 2n. Alright. Now this number should be a string because this starts with 00, right? We cannot represent 00 in an integer. Now the next part, 50 in a box. That means the quantity given is 50. The cost is 50.0. So with 50, then 50. I actually haven't realized, I just paused the recording when. Alright. So I was writing down the answer. So we can insert in two ways, right? So let's see the question. We need to insert a new value inside the product table. So the values are given here. Now I need to write the script. So we can insert in two ways. At first, we can follow the exact serial given here, right? So we insert into product values the ID. The ID needs to be string because it starts with 00. Then I have the blue ballpoint pen given here. Then 50 is the quantity, 5 is the cost, and the supplier ID is SFX223. Now we can use an alternate method where we insert into product, we mention the name of the fields, product ID, product name, quantity inbox, cost, supply ID, and the values. Then we add the values. So here we can alter the serial of the field if we want, if it is needed. Alright, next question. The attribute collected in the table order stores the boolean value true if the order has been collected and false if the order has not been collected. Write an SQL script to return the customer name for each customer that has orders they have not collected. Include the number of orders each customer has not collected with an appropriate title. An example output might be this. So here you have to run a query. Alright. So here let's start writing it down. Alright. So we need to select two fields, right? Select. At first I have the customer name given in the table above. Then I need to count. What do I count? I count the number of orders, right? So let's use the field order ID. Now I need to use the as statement because the here it is mentioned in the question we have not collected, right? So I need to use the as statement. Now then from I mentioned the table, so I'm taking it from the order, and this is collected by what? We have customer and order, right? So we have these two tables, customer and order. They are being connected by the customer ID. So I need to return the customer name for each customer and for orders that have not been collected. So I will use order table and the customer table. Now I will use where. Here I need to match two fields. Order dot customer ID is equals to customer dot customer ID. So I need to use a where statement. Sorry, and statement where I have to check that the collected is false or not, right? So here I will write order dot collected. Collected field is in the order table, so I write order dot collected. Now I check if this is equals to false or not. So if this is equals to false, all right, then I need to group by something, right? I will group by the customer ID because customer name might be different, might be the same, right? So use a field that is unique. Don't group by the name. Even though the data output is given with name, we need to group by the customer ID to make sure unique data is handled. And then we use a semicolon. Alright, this is one method, and let's try another method using inner join. So again, alternate. So select customer name. We are not mentioning the name of the table with customer name because both of the table has this, right? We do not need to be specific here. As not collected from order, right? So we have the order table. We need to inner join with what? The customer table. So inner join customer. Now we need to mention which field we are working on, right? So on which field? So order dot customer id is equals to customer dot customer id, where collected is equals to false. Now again same way, group by customer dot customer id, then a semicolon. All right, next question. The shop uses database management system. One feature provided by DBMS is data dictionary. The data dictionary stores the attribute names for table names, foreign key, primary key is in the database. Identify three other items stored in the data dictionary. So you need to identify three other items. You cannot use the items provided here. So we use the relationships here, right? Then we have the data types. We have the validation rule if required. Alright, let's write it another points to be safe. But you need to answer only 3 points in the question paper. Alright? I'm just writing here for the sake of the video. Alright. The DBMS provides a developer interface. Explain how a database designer can make use of the developer interface. So using the interface of the developer, we basically create database object, right? We create form or we add tools for our form. So let's write it down. Basically everything that you can do as a database designer, you can edit data, you can add data, you can create form, you can create different views. So basically, to create or modify or delete database objects, to create a form for data input, to add tools to a form, for example, drop down boxes, then buttons, to design a report to show the output in an organized manner, to add a menu to enable users to choose different actions or run different queries. So you can, if it's okay if you include 3 points from here. And the next question. A computer can perform logical and arithmetic shift. So arithmetic shift is something that didn't come in question papers that much. We only get logical shift. Alright. So in arithmetic shift, you keep the first bit constant and then you perform the logical shift. Right. So here, show the result of a logical shift left of 2 places on the 2's complement binary integer. So let's try this. So at first we have the logical shift, right? So that means these two logical shift to the left, so that means we remove 2 bits from the left. So we start from 0 0, we start from 0, this part 0 0 1 0 1 0, this is from the original number, and we introduce 2 more digits to the right, this becomes 0 0. All right, now we have an arithmetic shift of 3 places, so the first one should be constant, cannot change. All right, now we shift to the right. That means we introduce 3 zeros to the left. So we have 1, 2, 3 zeros. Then we start from repeating the number from here. So we have 0, 0, 1. Right? We have another one here now. Let's fix this. I think I have done a small mistake here because we kept 0 here. I didn't notice the 1 here. So in arithmetic shift, what do? We keep this bit constant, right? We give a 1 here. Alright. After that, if you perform 3 places to the right, that means I will copy 3 bits which comes from the first bit, right? So if this is 1, this bit should be 1. If this is 0, these 3 bits should be 0. Since this is 1, let's write 1 here. Now we copy from the number. We have 0 0 1 1. 0 0 1 1. So this is the answer. So questions from arithmetic right shift only came once, I guess. Alright, in this question paper. So please practice this and you should practice more. Alright, now coming to the next question. Here we need to perform a binary addition. So your working include any overflow bits. So we have 1 plus 1 which is 0. We have a 1 here. 1 plus 0 plus 0 which is 1. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 1 is 0. Left 1. 1 plus 1 plus 1 is 1. Left 1. 1 plus 1 is 0. Left 1. 1 plus 1 plus is 1. 1 and we have a 1 here. Alright, so we write the remaining one. So the remaining one is represented using a bracket like this. This is the overflow. So include any overflow bits. Alright, so we can use a bracket here. Then subtract the binary number from the binary number this using binary subtraction. So we can use two methods. One is the direct subtraction, one is the 2's complement. All right, so I will show you both of the method now. Let's start with the easier one. So what is subtraction basic? If I have a minus b, all right, if I have the operation a minus b, let's say I have the operation a minus b, that means this is equals to what? A plus minus b, right? So this minus b is actually the 2's complement of just b, right? So we can do this operation, and if we have two numbers, I can find the 2's complement of this number at first, then I need to add it to this number, right? So let's try that. So I have 0 0 0 1 1 1 0. If I have 1's complement, so let's try this. I am starting with this number, then I have to find the 1's complement. 1's complement becomes the, we just feed the bits, right? So we have 4 zeros and a 1 here. Now if we have 2's complement, this we just add 1 to the whole number, so this becomes 1 1 1 0 0 0 1 0, because 1 plus 1 is 0 and we have a 1 here, right? This is 2's complement. Now we do an operation which is adding both of the numbers, the 2's complement of this along with this number. All right, so we have this plus this, right? So if we perform the addition, we are going to get 0 1 1 0 0, 1 plus 1 is 0, 1 1 plus 1 is 1 1 1 plus 1 is 0, and we have a 1 here, right? Here this is actually being omitted, right? Because the answer will be in 8-bit. We are subtracting a smaller number from a larger number. All right, so coming to the next method, where we use a direct subtraction. All right, then we are the second number, 0 0 0 1 1 1 1. So this is a harder method and more risky method. All right, so you can check this if the value is okay or not by doing converting into denary and performing the operation to check, right? So 0 minus 0 is 0. Now we have a 0 here, right? So that means I need to borrow from here. So if I borrow from here, this becomes 1 0, right? So 1 0 minus 1 is basically 1. All right, so this becomes 0. So that means I need to borrow from the left, meaning from the left, meaning from the left again. So I have 1 0 here. So if I borrow from here, this becomes 1, and I have 1 0 here. If I borrow from here, this becomes 1, and 1 0 comes here. So 1 0 minus 1 is 1. 1 minus 1 is 0. 1 minus 1 is 0. So this is 0, right? So 0 minus 0 is 0, and 1 minus 0 is 1, and 0 minus 0 is 0. So this is the second method. All right, so all right, coming to the next here, subtract the binary number 23 from the 2's complement binary number 0 1 0 0 1 0. Perform this calculation using binary subtraction. That means you have to convert it into binary, then do the subtraction. All right, so you can use both of the method, it's okay, but let's use the boring method. So we convert 23 into binary, right? So 23 becomes 0 0 0 1 0 1 1 1. This is the value of 23. So we subtract this from this. So let's try this. Subtract this with 0 0 0. Alright, now let's perform this. So here I have 0 minus 1. So we remove this 1, this becomes 0, and this equals 1 0. So 1 0 minus 1 is 1. Now we have 0 here, we have 0, so we need to remove 0 from here. This becomes 1 0, and we remove 1. This becomes 1 0. So 1 0 minus 1 is 1, then 1 minus 1 is 0. 0 minus 0 is 0. Then we have 0 minus 1, so we remove 1 from here. This becomes 0. If you remove again, this becomes 1, and this becomes 1 0. So 1 0 minus 1 is 1. 1 minus 0 is 1. 0 minus 0 is 0, and this is 0. Alright, so this is the final answer. We need to write this answer here. All right, coming to the next question. So the next question is a database question. A shopkeeper repairs electronic devices, for example, mobile phones and tablet computers. The shop owner stores the data about the repairs using a file-based approach. The shop owner creates a relational database called Fixit. Is the name of the database. The database stores data about the customers and the devices for repair. Some devices need new parts that are ordered from supplier. The database Fixit is designed to include the following tables. So we are given a name of the tables. So the table shows sample data for repair part. So you are given this data. Alright. So write an SQL language to define the table repair part. Include constraints. So you need to include some restrictions on the data that can be entered into each field where appropriate. So we only use this where appropriate. So let's start. So we need to create a table. So we write the table name. Here the table name is repair part, which is given in the question. Then we start. So we are going to end with a semicolon. Now we write the name of the field, part ID. This is a variable character, right? Because the number of character is not fixed. So this is very varchar. Let's give it 20 or 30 or any high value. And this cannot be null because we include not null because we are told in a question to include constraints. So next line is repair number. We also give this a variable character. We can also include character here, but we are not told that it should always be 4. All right. So and this is not null. Then so next we have the third data type, which is quantity. This is an integer and this should also be not null. We now define the primary key. So the main thing is in this question there is actually a composite primary key, like primary part ID and repair number, right? So we have composite primary key. We need to use a separate. We need to use separate line to define the primary key, right? So we have part ID and repair number, and we in the bracket. All right, next question. The computer system is used to store data received from a temperature sensor every 5 seconds. The data is stored on an optical disk using an optical disk reader or writer. Describe the principal operation of an optical reader or writer. So let's just complete it with the points. So a disk is spun, a laser is shown on the disk using optical head to move it into position. It follows the spiral track from the center outwards. When writing, the laser burns pit to represent the data. When reading, the laser reflects from pits and lands or bumps differently. The reflection from pits and land is different. The difference is interpreted as 1 or 0. So basically, the intuition is we have a disk, right? And a laser is shown into the disk. So using an optical head to move it into position. So we can use the laser in different parts, right? So it follows a spiral track from the center outwards. So basically it is divided into spiral track and sectors like this, right? This is something you learn. So when writing, the laser burns the pits to represent the data. So using the laser you can burn the pit, or during reading you can reflect the laser from the pits. Alright, so using this reflection you can understand the zeros and ones. The computer uses a buffer when writing data to the optical disk. Explain the use of a buffer when writing data to the optical disk. So buffer is a very common question that comes. So the main mistakes that students make is they actually write that buffer stores data, which is not true, right? When a buffer stores data, that is true, but buffer does not transfer data. You have to make sure you write that. All right. So computer and optical disk reader or writer send and receive at different speeds. Data is transferred to buffer, then from the buffer to the optical disk reader. Buffer allows temporary storage of the data to allow both to send and receive at their speed. Alright, so what happens is I have a computer, right? So I have a computer and I have a disk. Alright, the speed of the computer and the speed of the disk might be different. their sending and receiving rate might be different, right? So we use something called a buffer as a temporary storage. Let's say the speed of computer is higher, that means it can send at a higher speed. So it that the disk cannot receive at that high of a speed. All right. So what happens is we store the data in a buffer. So the computer stores data in a buffer, and the disk takes data from the buffer to the disk. All right. So using this, we can actually use devices with different speeds. All right. So this is the main concept of buffer. So in many questions, actually in every past paper, whenever a buffer question comes, students make the mistake of writing that buffer stores the data. Buffer transfers the data. That is not true. Buffer only stores the data temporarily. All right. So I won't be answering any more buffer questions today. There might be more questions in the paper though. All right. Now, a car park system uses a camera to record the registration number of each car as it enters and leaves the car park. Explain how AI is used in a car park system to identify the car's registration number. All right. So, so basically, AI uses image recognition. The pixels of each image from the camera are stored and matched to the expected shape or size of color of the registration number. The pixels within the registration number are area identified and analyzed and compared to the expected characters of letters or number. Alright, so this is the process that happens. So it is a very common question. Instead of car park system, they might give you a different system where they use image recognition. Again, maybe to recognize a human, you basically compare with stored human data or stored human shape and all. They might ask you, instead of car, they might ask you to identify dogs or cats. Basically, you store many images of dogs and all. So this is how it works. All right. The programmer created a new program library while developing the program. Describe the benefits of the programmer of creating a library. So basically, using library, we can share subroutines between team members who are working independently. We can reuse subroutines in future programs without having to rewrite. We can save time because of this, right? Because once we create a program library, we only need to create program library once, and usually we don't do it. All right, some other developer maybe created a library, and we just use the library. So if there are any bugs, this will be fixed, and every single program that uses the library will be updated, right? So basically these are the advantages. Now, a company uses a relational database to store data about its customer, employees, and the individual repair jobs that customers have booked. The company decides which employees will work on each repair job. An employee can log into the database to access information about the repair jobs. The database is normalized and includes these tables. Customer stores personal data about each customer. Employee stores personal data about each employee. Login data stores the username and password for each employee. Job stores the data about each repair job. Job employee stores the employees that are working on each repair job. Identify each relationship between the database table and explain how this relationship can be implemented using a normalized database. So this is a question where you have to write and explain. So I would suggest you can draw a table by yourself if you want to make things easier. Alright. So main thing, basically I have let's write C for customer. Then I have E for employee, then J for job, JE for job employee, and LD for login data. Alright, so one customer can have many jobs, right? So customer to job is one to many. One customer is assigned to many jobs. Alright, one employee has one login data. So this is a one-to-one relationship between login data and employee. Alright, then one job has many job employee, right? So this is a relationship like this. One employee can have many jobs or be in many job employee. So like this. So this is a kind of relationship that we can make. So you have to explain whenever you have a relationship, there is four relationship here, right? So for each relationship, you basically have to explain what is the primary key, what is the foreign key, and how it is being used. Alright. So let's write it down. So basically one customer to many jobs. So we one customer have many jobs. Implement by primary key in the customer and there will be foreign key in the job. one employee has one login data, implement primary key in employee data, employees FK and in login data. So we can have foreign key in this table or this table, it doesn't matter because this is a one-to-one relationship. Now one job has many job employee, implement by PK in job, FK in job employee. So we have a primary key here and a foreign key here. One employee can have many jobs or be in many job employee, implemented by primary key in employee and foreign key in job employee. Alright, coming to the next question. The instruction set also includes this means bit manipulation instructions. So we are gonna use a table. Alright. The current content of accumulator is shown 100111010. The table has three sets of instructions. The binary number 100111010 is reloaded into the accumulator before each set of instruction is run. Complete the table by writing the content of the accumulator after each set of instruction has run. So let's write it down. So left shift, logical shift left by two places. Alright, that means these two will be gone. We start from here 0 1 1 0 1 0 and we introduce two zeros to the left, these two. Alright. And 5 after that and 30. So before every operation this is reloaded. Alright, so let's try this. Let's try this here. I have 1 0 0 1 1 0 1 0, right? So we are ending with 5. So 5 means what? 4. This is 0. This is 1, 2. This is 4. So this is AND 5. Alright. So after the first operation, the number becomes 0 0 0 0 0 0 0 0. Alright. So this is basically add 5, not AND 5. So we are going to add this. Alright. So this actually becomes 1 1. This becomes 1, this becomes 1 1 and this becomes 1. Alright, now I want to end with 30. So the value is 30 is what? So we are going to have 0, we have 2 4 8 and 6. If we add this we get 30. So if we do the AND operation, 1 and 1 1 and 0 is 0, 1 and 1 is 1, then 1 and 1 1 1, then we have the remaining 3 zeros. Now we have OR with this. So let's load the value again. OR with 4 ones, 2 0 1 0. Alright, if we do the OR operation, I have 0 1 0 1 1 1 1 1. Now if I increment the accumulator, this will add, we will add 1. So this becomes 1 1 1 1 1 0 1 1. Alright, next question. Ice cream company makes ice cream and sells it to shops. The ice cream is made in batches, a large quantity of one type and flavor of ice cream that is then split into smaller quantities for sale. The company's owner has designed a relational database ice cream to store data about the ice cream and customer. Some of the tables in the database are given. The database is not normalized. Alright. So write an SQL script to define the table batch, include constraint or restriction the data can be entered into each field where appropriate. So the main reason I gave this question is because of the mark scheme problem. Alright. So at first we have batch ID, which is variable character of 6. Alright, highest we are allowing 6 characters because it is not constant. Some has 4, some has 5. So let's write 6. Now type is variable character of 20. Alright, flavor is variable of 20. So these are all set to not null. Alright, then size is set to float. But this is the mark scheme answer. Alright, I'm editing it. So we don't actually use float in SQL. Alright, we don't also use currency in SQL, so we need to write real here. Now end date is date and primary key will be set to batch ID. Now coming to the next question. The next question asks us to normalize the table batch. Write a new table definition for new tables. Identify any primary key and foreign key in your tables. Do not change or include the table's customer and sale. So we make no changes to the table customers and sale. We only make changes to batch. Alright. So let's read the question again. So here in batch we have batch ID, type, flavor, size, and selling price, and end date. So here we are mentioned the ice cream is made in batches. All right, a large quantity of one type and flavor of ice cream that is split into smaller quantities for sale. So that means each type of ice cream will have flavor and it will have a type and a flavor, right? So we can name a table for ice cream, we can name a table for batch, and we can link it using another table. All right. Basically, the idea is I will have a table named batch, I will have a table named ice cream, all right, and I will link this with another table. So the basic idea is I will have a table batch, then I have ice cream, and I have an ice cream batch, and I have ice cream. I'll have many to many batch with ice cream batch and ice cream with ice cream batch. All right. So let's define the table. I have the table batch. Here the batch ID stays the same. Then inside that I can have batch ice cream ID, and the end date of the batch. So this is the primary key. Then I have batch ice cream. All right. So I have batch this field, cream ID, size, and selling price. This one is the primary key. All right. I need actually another field for ice cream, right? Ice cream ID. Now I have last field called ice cream. Here I will have ice cream ID, type, and flavor. All right. So this is the primary key here. This is the foreign key, right? This is the foreign key here. So this is the table. Explain how our DBMS supports data integrity. So basically, DBMS enforces referential integrity such as cascade update or delete. If data is changed in one place, it is updated in every other place. Entity integrity supports primary key as unique identifiers and provides different views to limit what user can access without authority. Now, describe the difference between a right logical shift and a right arithmetic binary shift. All right. So, basic difference is what? Whenever I use logical shift, every single bit is going to be changed, right? But if I have arithmetic shift, the first bit will stay constant. Now, if I am going to shift, whenever I add any bit, let's say I move this to the right, all right, I will add 1 1 to the left. So this becomes 1 1 1 0 0 1 0 1 0. All right, I am adding ones here. All right, so that is the arithmetic shift. So let's write it in Word. Alright guys, so the basic definition is logical shift moves all bits one places to the right and inserts 0 in the most significant bit. Arithmetic shift moves all bits one places to the right and copies the sign bit into the MSB. Alright guys, so for now I have did the hard questions from May June 2025 and October November 2024. So this video is getting too long, so I am going to do the remaining papers in some other videos. So if you want, you can watch that. Also, if you like the video, do consider giving me a subscribe or just giving a comment or a like to let me know so that I can continue doing something like this more often. Thank you guys, see you in the next video.